In this video, we're going to be looking at how descriptive statistics can help us avoid making errors when we go to model and analyze our data. We'll be using a real machine learning model to do this. Now, it's a very basic machine learning model. We'll be looking at the probability that someone died based on their age and the day that they filed the report, or the report was filed. But it will kind of give us a taste of what this looks like. Now, to do this, we're actually going to be using a special pre-built function that will allow us to do some diagnostics. So similar to how we've imported packages in the past, right? So we've imported pandas as PD. In this case, what we're going to do is we're going to directly copy a function into our code. So if you go to the website under resources, you'll see this link called helper functions. Once you click on that, you'll see a few different functions. The function you want is this def viz cm. So I'm going to highlight this and copy all of this code, right click on it and click copy. Now back in JUpyter, down in a new snippet, I'm going to right click and click paste. So now I've added this new block of code, which is a function called vizcm, and this is a visualization function. You don't have to worry about any of this. Just like when we import a module and you don't really have to know all the code behind the module, modules are really just combinations of these functions. So here we're directly copying this particular function into our code. So I'm going to go ahead and click run on this. And just like that. So now this is loaded in my code just like a module, and I don't have to worry about it at all. Now let's go ahead and start setting up our model. So kind of our play model where we're going to explore this. So let's type in ML select. So I'm going to select some data for our machine learning model. In this case, I'm going to use only those cases where the age unit is equal to years. So we're going to start there. So let's go ahead and run that. All right, so now let's take a look at our outcomes, because we do want to ultimately be predicting if someone died or not. And so we need to look at all these different outcome classes to figure out how we can manipulate our data to change those categories to either be death or no death. So let's take a look at what we're working with. So I'm going to use that counter function again. But this time we're going to use it on the machine learning select, and we're going to use it on outcomes. So this is going to give us a list of what outcomes we're dealing with. So if I scroll down here, this is the set of all of the different outcomes that were recorded. We can see, as we alluded to before, we certainly have death, right? So death does occur. There are 925 cases of just death. Nothing else happened. But we do also have a lot of other cases in which death is just one thing that happened, right? So they did die, but they also visited their healthcare provider. They did die, but they were also hospitalized. As we mentioned before, if we just use the fact that someone died and we're trying to predict that someone died, we can't simply say that category equals death, right? We can't simply say outcome equals death, and that's what we want to predict. Instead, what we need to do is search through all of these for the word death, and then if it actually has that word, then we're going to set the patient to a 1, something that indicates that they did in fact die. So first things first, let's first create a new variable in our data frame, and I'm going to call it patient death. And to start with, I'm going to set this to 0. So what this means in this case is I'm going to say that 0 means the patient did not die. So right now, to start with, every single patient is being considered alive. Now we want to change those values from 0 to 1 in the cases where they did actually die, when there was a death. So first, let's do a selection. We're going to do a slightly different selection here. So we're going to do select all the deaths, and we're going to do that with a string search. So in this case, we're going to do .str for string, and then contains. And this is the trick. So now we're looking through this data frame for every single case where the string contains the word death. So it's not a direct match like we've done before, but rather it's this contains search. So we'll go ahead and run this. And now we have this selection. Now what we need to do is this update, right? So you'll remember these are all set to 0. So now I want to set some of them to 1. So to do that, what we're going to do is something slightly different than we've done before. We're actually going to use an indexed-based lookup to change some of these variables. So in pandas, how we do this is we do df.loc, and that stands for locate. The first thing is what we're using for the locations. So in this case, we're using the selection that we just created. So we're saying, go in and locate any time when this is true. I want to know what row that is. And then I want to tell it, okay, in that row, I want you to change one value. And in this case, I want them to change the one value. I want the algorithm to change the one value that is in patient death. And I want the algorithm to change it to 1. So I'm going to go ahead and run this. Let's go ahead and take a look at this. So we're going to do df patient death. Go ahead and run this. And here we have all of these zeros and a couple of ones, right? So these are rows where there was a death. So the 80,000th row in this case did have a death. We can see here, so there's 80,000 different rows in this particular data set. So that's what we're working with in this particular data frame. So we now have this beautiful binary column with ones or zeros. A 1 indicates that a patient died. And what we actually want to do with that is predict the probability a new patient might die when they come into the hospital. So if a patient comes into the hospital and they have a certain age, then maybe we can predict, how seriously do we need to take this? Now, this is obviously a very rudimentary model. In practice, you would use a lot of different characteristics to do these types of triages, but let's pretend we're just going to use age and the date you're walking in. So the first thing we'll have to do is we want to actually get the date field working, right? Because I want to use the date to predict the likelihood of death. So just the logic behind this real briefly, the later it is, right, if you're in 2018 versus 2000, you're much more likely to live because medical healthcare has advanced, right, just because we get better at things over time. So let's control for that. The first thing we have to do, though, is look at what our actual data is. So let's look at df, date of event. So this is the date that the event, the choking or whatever happened. We can see, first of all, there's a lot of NA data. So we will have to eventually take care of that. But more importantly, these are not numbers, right? We constantly run into this problem of we have data that is not numbers. So the common way that this is taken care of in kind of data science is we select one date in the past. Generally some date in 1970 or 1990. It really doesn't matter what the date is, but some date. And you calculate the number of days between this date and the date you choose. Between this date and the date you choose, between this date and the date you choose. So this value, instead of being December 5th, it would be, 10,545 days. And this one might be 10,555 days because it's 56 days because it's 11 days later. And that allows you to have a numeric that represents these dates that a computer can use in a model. But we have to get there. All right, so let's go ahead and start that conversion. So first and foremost, we have to tell Pandas that the column that we're working with is in fact a date. It doesn't inherently know that it's a date. It'll just think it's a string otherwise. So that's what this PD datetime does. We are going to save this into a new column of data, which I'm going to call date numeric. So I'm going to set date numeric, my new column, equal to this new, basically just telling Pandas this is a date. And then what I'm going to do is I'm actually going to subtract from this date another date that I'm going to make up. So Pandas to date frame, and I'm going to use 1970. So we're going to use the first day of 1970. So this will give me that difference, but what I actually need to do to get the difference in days is put parentheses around the entire thing, right? So I'm going to do that one more time. So you see right here at the very beginning, I'm going to put a parenthesis, and at the very end, I'm going to put a parenthesis. So I have two parentheses here, right? One is closing the to date frame, and the other is closing this entire statement. And now I'm going to put a period and put DT, stands for date times days. And so if I run this, I'm now calculating the difference between every single date. To date time. So when I run this, I'm now calculating the difference between every single date in the first day of 1970. So let's actually take a look at what came out. And here we go, right? So this now is 16,000 days. You'll remember the example I gave earlier, it was 11 days different, right? So 1644, 1655. So we see these differences pop out in days now, and these are numbers, so we can actually use these in analysis. So now we have two numbers we're going to use, age and date of event. So we're going to use those two to actually fit our model. Now, the first thing we have to do is remove NA values, right? We have all of these NA values that are not going to work in our model. There's nothing we can do with them. We'll talk a little bit later in this course about how you can impute and try to fill in missing data, but we're not going to do any of that now. What we're going to do instead is we're going to create a new data frame called no NA data frame, and we're going to do that by doing df.dropNA. And all this is going to do is drop every row that has an NA. So it's a very messy way to get rid of data. You lose a lot of data unnecessarily, but we're just going to run with it for now. So let's go ahead and click run on this. And then we'll look at our new data frame, our no NA, same date numeric. And you see now everything has a value because we've removed everything that did not have a value. So now we actually need to get into the nitty-gritty of our model. Now, this is a very arbitrary machine learning model I'm choosing, and you just don't need to know the nuances of it yet. It's something called a classification tree. So type in from sklearn.tree import decision tree classifier. So this is the module, and again, this is just like installing a program. We're going to use this tree. So then let's define our machine learning model. I'm going to call it machine learning model, and we're going to set that equal to a decision tree classifier. And for this, set the random state equal to 1693. So this will ensure that the results I get match the results you get. So this is a classifier that basically is going to attempt to go through our data and predict if someone is likely to die or not, right? If patient death is a 0 or a 1, based on the date of event and an individual's age. So that's the goal that we're working on here. Now, to do this, we need to define two things. First, we need to define the variables that we're going to predict with. So I'm going to call this variables we predict with. This is frequently called X as well, but I'm just going to write this out in long form. And so this will be the no NA data frame, 2 brackets, because there's going to be multiple variables. The first one, we're going to use patient age, and then comma, date numeric, the field that we created. And then at the end of all this, dot values. So to break this down, we want to predict with 2 variables, patient age and the numeric date we built up here. We want to get those variables from the no NA data frame, and we need the values from that. And the reason we need these values, we actually don't need a pandas data frame for the classification model we're going to be using. We need the raw numbers. So that's what we're doing there. Second thing we need is the variable we want to estimate. So I'll write this out in long form again. Same data frame, the no NA. And in this case, we want patient death, right? So this is the same variable we created again. This is the 1 or the 0. So we're going to predict this. Now we're going to actually do what's called fitting our model. So this is, kind of going in and doing the actual machine learning. This won't show us anything. It'll just tell the computer to go ahead and do the work. So mlmodel.fit, and we put 2 things: the variables we predict with, and the variable we want to estimate. Right, so those are the 2 kind of variable names. Again, you can call these X and Y, but this kind of makes it very clear what's going on. So we can go ahead and run this, and it will take a moment to run, so you can see the star. And so there we go. So we've now fit our first machine learning model, but we can't really, see anything, right? There's no real clear data. So what we're going to use is that viscm function that we got from the website. So I'm going to type in viscm, and then in parentheses, the model. So this is the model that we actually want to take a look at. I'm going to type in the labels. And we have two different X variables that we're putting in here. So I'm going to put in the labels are age, comma, days since Jan 1, 1970. So those are our 2 variables. And then we have 2 different variables we have to define. So we're going to do X equals the variables we predict with, and Y lowercase equals the variable we want to estimate. Right, so this will tell it, visualize the results from my model, where the labels for my model visualization are these 2 labels, the age and days since 1970. X is the variables we're predicting with, and Y is what we're trying to estimate. So this will give us a nice visualization of what the model actually did. And this will take just a moment to calculate the visualization. And you can ignore these warnings if they come up. So this is the actual outputs from that particular classification tree. Now, what in the world are you looking at? Every single green dot. So let's take this green dot, for example, right here. That green dot is someone that was age, let's call it about 10. So that green dot's at around 10. And days since January 1, 1970, let's call it around 16,000. So that means someone that walked in days 16,000 and age 10, they died. So what, whatever reason, when I don't know what they ate, I don't know anything, but they ate something and they died. That's represented by a green dot. Every single one of these green dots is a case where they died. Every red dot is a case where they did not die. So what do we see here? These green regions, this is where the model is going to predict that someone will die. So these two green dots right here are cases where we're getting it right? So we're actually predicting an individual will die in those two cases. This case right here, the model is getting it right. All of these cases up here, we're getting it wrong. Now the flip side, the negatives, right? We're getting a ton of those correct, right? All of these red dots here we're getting right because they're all in a red region of the model. This is a pretty common problem in machine learning where we have a huge, huge number of cases where there was no problem. No one died. So let's take a look at how we could diagnose that using descriptive stats. Very straightforward. NoNA data frame. Let's get the patient death. And you'll remember this is a 1 when it's something that happened, it's a death, and a 0 when it didn't. So I'm just going to look at the sum. So 244 cases where there was actually a death, and that is out of 236,000. So your model, because your model wants to be as accurate as possible. That is the sole purpose in life for your model. Your model is almost always going to predict 0. It's almost going to always predict no death, because if it predicts no death every single time, it's going to get a lot of answers correct. And so unless you have a very, very clear-cut case where you're just going to get more, like here, where you're not really misclassifying anything, you're always going to get this style of a prediction. So that's a model balancing issue is what that's referred to. So last thing I'm going to do, and I'm not going to walk you through this step by step because you don't really have to worry about it. So this section of the video is going to get fast forwarded so that you can just see what the result is. What I'm going to do is I'm actually going to go in and I'm going to create a balanced version of this model so you can see the difference. All right, and here we go. So this is an example of a balanced model. So what I've done here, I'm not going to go into detail of the code because you don't need to know the details right now, but the basic idea is I've made it so there's an equal number of death and just kind of sick cases, so individuals that did not die. Again, the red ones here are the cases where they did not die because those are zeros. The green ones are the cases where they did, so those are ones. We have the evil villain color scheme going on here. What you can see here, so let's compare this plot to this plot. So here in this plot, the green dots essentially had no weight. The model didn't care about the green dots because there were so many red dots. Whereas here, the model cares a lot about the green dots, right? It's cutting large portions of its space out so that it will actually classify those as green. So what this means is, if we used this model, I mean, no hospital in their sane mind would use this model, but if you were to, and someone the age 50 walked in, and they walked in 15,500 days after 1970, January 1st, 1970, you would predict they're going to die. Conversely, up here, same person walks in 15,000 days, you're probably not going to predict they're going to die, right? Like you're going to predict they're going to live. And so you get fundamentally different answers from your models, just depending on how well you balance your classes of data. So that's it for model description. Model description is a key step of any analysis, and you really need to spend the time to get to know your data.